Hello everyone, my name is Max. I work for the City of Santa Cruz for the Water Department. I am a ranger up here at Loch Lomond. So I'm going to be talking to you guys about turbidity and what that means for your water quality and the water quality of the Loch Lomond Reservoir. Turbidity is caused by small, very, very small particles suspended in the water. Now, this isn't like taking a handful of dirt and throwing it in a bucket of clean water, because that dirt will settle down. It will settle out to the bottom of the bucket, or in a river or in a reservoir. Those types of larger molecules will settle to the bottom. The molecules I am talking about are very, very, very small. And I have a picture that you will get a close-up of here in just a second, but there's two different types of turbidity in this one river. Now, the part that looks blue, that is considered very low turbidity. Now, I said before, turbidity is caused by suspended particles in the water. Low turbidity means there's not a lot of particles suspended. This part of the river that looks like chocolate milk, that has very high turbidity. There's lots of particles suspended in the water. So the water you get from your tap in your house, pretty clear. That means it's very low in turbidity. Turbidity also does not mean that there is a lot of bad things in your water. A lot of the water that comes from Santa Cruz area and goes down to the treatment plant is relatively high in turbidity, especially during a storm. Storm comes through, mixes up the water, runoff from the land, catches water and dirt and particles of leaves, that flows into the water, stuff can decompose, that can all add to turbidity. Turbidity can be caused by agricultural runoff, it can be caused by construction sites that have dust blowing off of them into water, or some people just really don't care about water quality and choose to dump things into rivers. The turbidity in this picture, I don't know the source of this turbidity, but it does show that turbidity is not exclusive to a body of water. So turbidity may be different upstream than it is downstream on a river. The turbidity at the farthest part of our reservoir may be much different than what's down by the dam. So I have personally collected some water, but this water, it's from a spigot. It's been treated. I have also taken the liberty of getting some water from the reservoir. Now, that has not been treated. That is what's considered raw water. If you want to see them side by side, treated water, raw water. Now, if you had to guess, which one would you say has higher turbidity? Well, I told you about suspended solids, and the more suspended solids you have in your water, the higher the turbidity. I would venture to guess that maybe this guy right here has the higher turbidity. And it does. So, I have explained to you what turbidity is and some common causes of turbidity. But you still need to know how to measure turbidity. The way we measure turbidity, since we're at a reservoir, a large and deep body of water, we use this guy. It is called a Secchi disc. Now, this Secchi disc is used by going out into the middle of the lake or reservoir. You undo this and it drops in. That is all fine and dandy if you've got enough depth to be able to use your disc. If you can't, you use this guy. This is called a transparency tube. Now, it serves the exact same function as the disc. With the disc, you drop it down till you can't see it anymore. Then you stop and you count. With the transparency tube, it's kind of like the inverse or opposite of that. You pour water into this tube, a full tube. Got a little clamp down here that's clamped down to keep the water in. Once you have a full tube of water, if it is turbid enough, you would look down the tube and you wouldn't be able to see a little Secchi disc down at the bottom. So, if you were using the transparency tube, you'd fill it all the way up to the top. You'd look down. I can't see the bottom. I can't see my black and white pattern. So, I would pop the tube. Water would flow out, but the whole time that water is flowing out of the tube, you have to be looking down. My arms aren't quite this long, so I would need a partner to use this tube, but you would look down and you would say, no, I can't see the disc. No, I can't see the disc. And as soon as that black and white pattern comes into view, you clamp it back down and you'd have a water level, say it was about this. Water level's here, and that is the first sign that I can see the bottom. That's where you would take your measurement. So you would count from the bottom, 10, 20, 30, 40, 50, 60, and right in between at that arrow, we'd have a measurement of 65, and our units on this are centimeters. Units are very important when it comes to science. Hello again, folks. We are out on the reservoir now. We have tucked ourselves into a nice little cove here, and I'm going to give a demonstration of the use of the Secchi disc. So, you're out here on the lake, on the reservoir. You need to come check the turbidity. You would come over with your Secchi disc. Got plenty of line let out already. Come over with your Secchi disc. You'd go right over to the side of the boat and you would drop your disc in slowly. Now, you keep dropping the Secchi disc as long as you can see that black and white pattern. It's black and white, so it contrasts with each other and it makes it more visible. So, it'll go down and down and down, and you would stop letting the Secchi disc out when you can no longer see that. So, sometimes you're going to get a reading of 5 feet, which is very turbid. Sometimes you'll get a reading of 25 feet, which is not very turbid. That's pretty good. Now I'm just barely losing sight. I can still see my white against the black down there. And I'd probably call it about there. So from there, where the water line is on my rope, I grab there. So then I pull this up, and from here, it just so happened to be on one of my black marks. These are each 1 foot. So I'd start here, and I'd go 1, 2, 3, 4, 5, 14, 15, 16, and 17. So we got a Secchi dip of 17 feet at this specific location. Now, like I said before, this can only be used when you have enough depth. The transparency tube, that only goes up, I think it only went up to about 100 or 110 or so centimeters. You're not gonna get 17 feet on the transparency tube. And right now, 17 feet for a Secchi dip, pretty good water quality. That's pretty good water quality. And this is the water, we're in the reservoir, this is the water that goes down and gets treated at the treatment plant, and you guys eventually drink out of your tap. We just got a reading of 17 feet on our Secchi dip. You go to your journal, you're gonna go to that second page like you had with the other videos, and turbidity is all the way down at the bottom of page 2. It's the last one on that table, and to the right of turbidity, it says high, medium, and low, and it wants you to circle one. Just above that is a line and some parentheses. On the line, we're gonna write the number that we got, and then in the parentheses, you're going to write the units that we are describing. So in the transparency tube in the river, you'd be doing centimeters. For the Secchi disc, it's going to be feet. So in the parentheses, go ahead and write FT. 17 was our measurement. And before, I told you that high turbidity is a lot of suspended particles in the water. Low turbidity, very, very low, almost no turbidity, is clear. That's what comes out of your tap. So, you're gonna have to circle high, medium, or low. That poster you saw earlier with the two different types of turbidities, the one that was blue, probably low turbidity. The one that looked like chocolate milk though, that's very, very high turbidity. This doesn't quite look like chocolate milk. So, it is up to you. It is your data as a scientist to record this. So if you would like to put high, you may. From a professional standpoint, I don't know if I would put high. I don't think I would. You could make a case for low, but certainly medium turbidity right now. It's not the best turbidity we've ever seen, but it is certainly not the worst. So, medium low, that's probably your safest bet.